Problem number 16. See here, how many numbers lying between 10 and 1000? Lying between 10 and 1000 means more than 10, less than 1000. Can be formed from the digits 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Repetition is allowed, means repetition we can do, means duplication can come. Okay, so see here, 1, 2, 3, 4, 5, 6, 7, 8, 9. So the first condition is how much? How many numbers lying between 10 and 1000? 10 and 1000 means 11 to 99. So 2-digit numbers. How many 2-digit numbers are there? See, 2-digit numbers. 2-digit numbers, one condition. Next condition is 3-digit numbers. 3-digit numbers. Can you get 4-digit number? No. The first 4-digit number is 1000, but what they are telling, between 1000 and 10 means 10 and 1000. Between these two means you have to consider only the middle one. You have to exclude 10 and you have to exclude 1000. So you are going to get only 3-digit number. So 2-digit number, how many spaces are there? Come to the first one. 2-digit number, you are going to get only 2 space. These 2 space has to be filled by how many values? 9 values. So here you can get 9. But in the question they are telling that repetition is allowed, means whichever the number has come to the first position, the same number can come in the second position also. So here 9. So altogether 9 into 9, 81. So 9 into 9, 81. So you have 81 numbers between 10 and 100. You have 81 numbers between 10 and 100. Next, with repetition. Next, second one, 3-digit number, 999. Okay, so the repetition you can allow. So the first position 9 numbers can fill, second position 9 numbers can fill, third position 9 numbers can fill. So 9 9s are 81, 81 into 9, 729. So altogether how much you got? 729 plus 81. So which is equal to 10, 1 carry 10 plus 1 11, 1 carry 810. So you got 810, therefore option B is right answer. See here, only thing is what you have to identify is how many 2-digit numbers you are going to get and how many 3-digit numbers you are going to get. So 2-digit numbers are 81, 3-digit numbers are 729. In 2-digit number, you should not accept 10 because they are asking us to calculate between 10 and 1000, means you have to exclude 10. Okay, so after excluding, you got 81. Okay, so 81, 729, after adding both the two, you got 810. So option B is the right answer. Okay, let's move on to the next problem, problem number 17. Problem number 17. From 17 to 20, find the number of permutations that can be made from the letters of the word omega, O-M-E-G-A. First thing what you have to notice, whether any letters are repeated or not. See here in omega, no letters are repeated. So it's fine. No need to divide. Okay, next. See the condition. O and A occupying end places. See how many places are there actually? 5 places are there. 1, 2, 3, 4, 5. So O and A can occupy end places means O can come here, O can come here. And A can come here, A can come here. So end places, both O can come in the first place. See, O can come in the first place and A can also come in the first place. O can come in the end place and A can also become in the end place. So you have how many ways? 2 ways. Okay, in two ways. See, this O and A, you have 2 ways. So 2 ways in 2. Next, M-E-G. M-E-G. So how many letters? 3 letters. So it can be filled in 3 factorial ways. So 6, which is equal to 12 ways. So which is equal to 12 ways. So option A is the right answer. Let me repeat again. O and A has to occupy the end places. So the first place, can O come or A come? If O comes in the first, A goes to the last. If O comes to the last, A comes to the first. So you have 2 ways. 2 into. In the middle, how many ways you can arrange? 3 factorial ways you can arrange. 3 factorial means 6. So 6 into 2, 12. So option A is the right answer. Okay, let's move on to the next problem. Okay. E being always in the middle. See here, omega, O-M-E-G-A. So how many letters? 5. 1, 2, 3, 4, 5. E always in the middle means E place is fixed. Then how many spaces are there? Here 2, here 2. So how many factorial? 4 factorial. 4 into 3 into 2 into 1. So 4 3s are 12 into 2, 24 ways. Very simple. E is coming in the middle, means out of 5 E is getting 1 space. So how many spaces are remaining? 4 spaces are remaining. These 4 spaces has to be filled with other 4 items. E already it's over. So O is having 4 space, so 4 chances 4 into 3 into 2 into 1. So altogether you got 24 ways. Option B is the right answer. So you got 24 ways. Option B is the right answer. Okay, let's move on to the next problem. Problem number 19. Ovals occupying odd places. So omega, O M E G A. So what are the ovals? A, E, O. So these 3 ovals are there. Ovals has to occupy the odd places. See here, 1, 2, 3, 4, 5. Odd places means what are the places? The first place, the third place and the fifth place. So these are the odd places. Okay, from left towards right you have to go. From right towards left you should not come. Always from left towards right you have to go. So how many letters are there? Ovals? O, E, A. So these 3 letters are having 3 spaces. These 3 letters are having 3 spaces. So A can come in the first place, A can come in the third place, A can come in the fifth place. So it is having 3 chances. So 3 into, next O is having two places. So 2 chances into 1. So the remaining items are M and G. So it can fill the remaining 2 items. So how many values? Sorry, how many spaces? 2 into 1. So what is the value? 3 2s are 6 into 2, 12. So you got 12 ways. So very simple. If you split in this manner, then it will be very easy for you people to calculate. So 3 into 2 into 2 into 1 into 1 is the answer. That is 12 ways. So very simple to understand. Okay, let's move on to the next problem. Problem number 20. Problem number 20. Ovals being never together. See here the word called omega, O M E G A, omega. Here the ovals being never together. So which are the ovals we can see here? A, E and O. So ovals should not be together. So how to calculate this one? See here, total number of ways minus ovals together. Ovals together. Ovals together. So this is the best strategy to calculate, because it is very easy to calculate how many ways the ovals can be together and what is the total number of ways. See here, omega, O-M-E-G-A, O-M-E-G-A. So you have 5 letters, means 5 positions, 1, 2, 3, 4, 5. So how many letters? 5 letters. So 5 into 4 into 3 into 2 into 1. So which is equal to 120. This is total number of ways. This is total number of ways. Now ovals together. Ovals together means, see here again, 1, 2, 3, 4, 5. Ovals means A, E, O. So 3 positions. So here one variety, the first 3 positions it can fill, the second 3 positions it can fill, the third 3 positions it can fill. See here, let me repeat, the first 3 positions it can fill, the second 3 positions it can fill and the third 3 positions it can fill. So 3 ways. Next 3 into, next if I fix these 3 spaces for A, E, O, again A, E, O is, see here, A, E, O for these 3 spaces. So A can come in the first place or the second place or the third place. Again E can come in the second place or first place or third place, like that for O also. then how many ways it will be? 3 into 2 into 1. So which is 6, 3 into 2 into 1, and another only 2 into 1 ways, 2 into 1 ways. Okay. So 3 3s are 9, 9 into 4 36, 9 into 4 36. So ovals being together you have 36 ways, total number of ways is 120. So your final answer is 120 minus 36, that is 84, that is 84. So option B is your right answer. Very simple guys, total number of ways you calculate minus ovals together. How many ways are there? So that ovals being together. So total number of ways is 120, ovals being together is 36. So 120 minus 36, that is 84. So 84 number of ways we are going to get where ovals never being together, okay, in the word called omega. So very simple, in the ovals being together you have to properly calculate, so that 5 spaces, in those 5 spaces 3 types or 3 varieties of places the ovals can fill, that is 3 ways, and in those 3 vases A, E, O can occupy any of the places. So the number of ways will be 3 into 2 into 1, and the remaining place will be 2 into 1. So altogether 36. So 120 minus 36, that is 84. So altogether 84 ways. Problem number 21. See here, in a party 12 people are from same city. How many handshakes can be done among these 12 people? So 12 people are there, that is the total population. Next, how many handshakes can be done? So if you want to do an handshake, how many hands are required? 2 hands are required. So among 12 people, you want 2 members to do handshakes. Okay, among 12 people, you want 2 members to do handshakes. Okay, so that is nothing but 12C2. So 12C2 means what? 12 factorial by 12 minus 2 factorial into 2 factorial. That is 12 into 11 into 10 by 10 factorial by 10 factorial into 2 factorial means 2 into 1. 10 factorial get cancels, 2 6 are 12. So 11 into 6 you are going to get 66. Therefore option C is the right answer. Very simple. Out of 12 people, you want 2 members to do handshakes. So out of 12, you want to select 2. So how many ways you can select 2? Those many ways you can do handshakes. So 12C2 is the answer. Very simple. Okay, let's move on to the next problem. In a meeting between 2 countries, each country has 12 delegates. So you have 2 countries, country 1 and country 2. So 12 delegates from one country and 12 delegates from second country. All the delegates of one country do their shake hands with all the delegates of other country. Means the first country is doing their shake hands with the second country, but among them they are not shaking their hands. Okay, so with other country only they are shaking their hands. Okay, find the number of handshakes. Okay, so 12 members has to shake their hands with 12 members. So 12 into 12, the answer is 144. 12 into 12, the answer is 144. Option B is the right answer. Okay, very simple thing. Option B is the right answer. You people have learned so many varieties of problems among permutation and combination which may appear in the bank exam. See here, this video is concentrated only for the bank exams, not for the other levels. Okay, if for the other levels we could have concentrated, means still so many varieties we could have included, but we are concentrating only for the bank exams. Because of that reason, whichever the problems which may come through the bank exams, we have estimated. Based on that, we have presented a video. Please understand the problems whatever we have did in this video properly. So many problems what we have taken was very similar to the problems which have appeared in the previous year exam. Okay, so please refer the previous year papers, go through the problems whatever we have solved in our video, and please understand the introduction properly and solve the problems which we have uploaded in our website. Go through the worked examples regarding permutation and combination, take the mock text subject wise and the whole mock test. Okay, so it helps you a lot. My sincere suggestion, again I am telling you people not to skip the problem regarding the permutation and combination. Okay, one thing you have to believe, that is permutation and combination is very easy, very easy, very easy. You have to give the instruction to your mind that permutation and combination is very, very easy. So one more instruction what you have to give to your mind is, whatever the problem may come from the permutation and combination, you are good enough to solve those problems. Okay, these type of instructions you have to give to your mind, then only the problems related to permutation and combination will be very, very easy. Learn the concept, practice well, get the marks. Okay, max to max 20 to 30 seconds it is required for you people to solve the problems. Okay, practice well, attend the problems and clear the exam. Thank you.